Let us now work on some integrals that involve trigonometric functions. We familiarize ourselves with the following formulas that involve trigonometric functions. So the integral of sine u du is negative of cosine u plus c. The integral of cosine u du is sine of u plus c. The integral of tangent u du is ln of secant u plus c, or equivalently the negative ln of cosine u plus c. The integral of cotangent u du is ln of the absolute value of sine u plus c. The integral of secant u du is ln of the absolute value of secant u plus tangent u plus c. And finally, the integral of cosecant u du is ln of the absolute value of cosecant u minus cotangent u plus c, or the negative of ln of the absolute value of cosecant u plus cotangent u. Each of these formulas can be verified by getting the derivative of or the differential of the right side. Let us say we derive the integral of secant u du equal to ln of the absolute value of secant u plus tangent u du. So we verify, we verify the formula. So we take on the derivative of ln of the absolute value of secant u plus tangent u plus c. The derivative of ln is 1 all over secant u plus tangent u multiplied by the derivative of secant u plus tangent u, which is secant u tangent u for secant, and then plus secant squared u for tangent u. Of course, the derivative of c is constant. So for the numerator, we factor secant u. We have here tangent u plus factoring secant u from secant squared u gives us secant u all over secant u plus tangent u. And see that these two will cancel, hence we have secant u. Okay, so we can do the same thing for all the other formulas. Let us now solve for the following problems. The integral of sine of the quantity 3x minus 2 quantity dx. So this is of the form sine of u. So we check the differential of 3x minus 2. So if u is 3x minus 2, then its differential is 3 dx. And we know that we need to complete our du by multiplying or introducing 3 and by multiplying it by 1/3. So our answer here will be 1/3, and the integral of sine u is the negative of cosine of u, or 3x minus 2 plus c, or negative 1/3 of cosine 3x minus 2 plus c. Next, the integral of x tangent x squared dx. At this point, we should have realized that x is important because that is part of the differential of x squared, which is 2x dx. So our u here is x squared and du is 2x dx. So x dx is part of the differential of u except for the missing constant 2. So we introduce 2 as part of the integrand and we multiply it by its reciprocal 1/2. And the integral of tangent u is ln of the absolute value of secant u or secant x squared plus c. Applying one of the properties of ln, 1/2 becomes the exponent of secant x squared. So we can write this as ln of secant x squared to the 1/2 equivalent to the radical square root of secant x squared plus c. Next, let us evaluate the integral of cosecant 4x times the quantity cosecant 4x plus cotangent 4x. So distributing cosecant 4x, we have the integral of cosecant 4x times cosecant 4x or cosecant squared 4x plus cosecant 4x cotangent 4x quantity dx. The first integral is of the form cosecant squared u, where your u is 4x and the differential is 4dx. So the answer there will be 1/4, and the integral of cosecant squared is negative cotangent of 4x. Plus, for the second integral, it is of the form cosecant u cotangent u. And once again, your u is 4x. The differential of 4x is 4dx. So 1/4 will figure out in our answer, and the integral of cosecant u cotangent u is negative cosecant u or cosecant 4x plus c. So we can factor negative 1/4 cotangent 4x plus cosecant of 4x plus c. Right? So the next one is the integral of cosine 2t tangent 2t plus sine 2t dt. So again, we distribute cosine 2t. Thus we have cosine 2t tangent of 2t dt and plus cosine of 2t sine of 2t dt. Now we know that tangent is sine 2t over cosine 2t. So by doing that, we can cancel cosine 2t. So that simplifies to the integral of sine 2t dt. For the second one, we have or we apply one of the trigonometric identities, which is equivalent to 1/2 of sine 2 times 2t or 4t dt. Sine 2 theta is 2 sine theta cosine theta. So that is the identity we are applying to the second integral. So that is equivalent to sine of 4t. So integrating sine 2t dt, your u is 2t, the differential is 2 dt, so we have 1/2. And the integral of sine is negative cosine 2t. For the other integral, we have sine 4t dt. Again, we check on the differential of our u. Our u is 4t and the differential is 4 dt. So that will be 1/2 and because of the differential 4 dt, we have 1/4, and the integral of sine is negative cosine of 4t plus c. So answer here is negative 1/2 cosine of 2t negative 1/8 cosine of 4t plus c. Next, we evaluate the integral of e raised to 2x all over cosine squared e to the 2x dx. What we do here is we take on the reciprocal function of cosine, which is secant. Since this is 1 over cosine squared, we can write this as secant squared e to the 2x and e to the 2x dx. So obviously, the formula involved here is secant squared u du. So u is e to the 2x and du is e to the 2x times 2 dx. So the missing constant is 2. We already have e to the 2x dx. So our answer here is 1/2. And the integral of secant squared u du is tangent of u, or tangent e raised to 2x plus c. Next, the integral of the quantity 3 plus 2 secant t over 2 quantity squared dt. What we do is we expand to 9 plus twice the product of 3 and 2 secant t over 2, that will be 12 secant t over 2 plus 2 secant t over 2 squared becomes 4 secant squared t over 2 quantity dt. Term by term, we integrate. 9 dt will be equal to 9t plus 12 secant of t over 2. Your u is t over 2, so du is 1/2 dt. So the required constant to complete our du is 1/2. So the reciprocal of 1/2 that we'll figure out in our answer is 2. And the integral of secant is ln of the absolute value of secant t over 2 plus tangent t over 2 plus 4 secant squared. We know that the integral of secant squared is tangent, but we again check our u and its differential. So t over 2, the differential is 1/2 dt, so that will be 2 in our answer, and the integral of secant squared is tangent of t over 2 plus c. So final answer here is 90 plus 24 ln absolute value of secant t over 2 plus tangent of t over 2 plus 8 tangent of t all over 2 plus c. So we continue with some more examples. The integral of cosine squared 2x cosecant 2x dx. Now, we know that cosecant 2x is equivalent to 1 over sine. So let us write it as cosine squared 2x and then 1 over sine of 2x dx. Okay? So what do we do next here? For cosine squared 2x, we can apply an identity equivalent to 1 minus sine squared 2x all over sine of 2x dx. Alright? So it comes from the identity sine squared theta plus cosine squared theta equal to 1. Now we divide each by sine 2x, and 1 over sine is actually cosecant 2x. Then minus sine squared 2x over sine 2x is of course sine of 2x quantity dx. So we can now evaluate the integral of cosecant 2x. U is 2x, du is 2 dx, so we have 1 half. And the integral of cosecant is ln of the absolute value of cosecant 2x minus cotangent of 2x. Minus the integral of sine 2x is negative 1 half. No? 1 half because of the differential of 2x, which is 2 dx. And then the integral of sine is negative cosine of 2x plus c. So that will be equal to ln. We can use 1 half as the exponent of cosecant 2x minus cotangent 2x. So we write here the square root of cosecant 2x minus cotangent 2x. And then negative times negative 1 half is of course positive 1 half cosine of 2x plus c. Next, the integral of sine of x over sine x plus 1 dx. Alright, so what do we do here? We have 1 plus sine x. If we multiply both numerator and denominator by 1 minus sine x, our denominator will become 1 minus sine squared x. And by doing this, we can transform our denominator into a monomial term, because we know that 1 minus sine squared x is equivalent to cosine squared x. Alright? And then the numerator is sine x multiplied by 1 minus sine of x there. So what do we have? Sine x times 1 minus sine x is sine x minus sine squared x all over cosine squared x dx. So we split this into two integrals. Sine x over cosine squared x, which I can write as cosine to the negative 2x sine of x dx. And then minus sine over cosine is tangent. So the sine squared over cosine squared is tangent squared x dx. Okay, so for the first integral, we can apply here the power formula, where u is cosine of x. Your du is negative sine of x dx. Okay, so it only lacks negative 1. So we write negative, and then apply the power formula to cosine to the negative 2. It becomes cosine raised to negative 1 over negative 1 minus. As for tangent squared x, well, what we do is we apply here an identity from 1 plus tangent squared theta equal to secant squared theta. Your tangent squared x will be equivalent to secant squared x minus 1. Okay, so we integrate secant squared x minus 1 dx. Okay, continue. Negative times negative 1, that will be positive. And cosine x raised to the power of negative 1 is 1 over cosine or secant x minus. We then integrate secant squared x, which we know is equal to tangent of x. And then minus 1, that will be positive. The integral of dx is x plus the constant c. Okay, the next one is the integral of the square root of 1 minus cosine x over 2. Well, we have to apply an identity here. Recall that sine squared theta is equal to 1/2 of 1 minus cosine 2 theta. So let us compare these two. 1 plus or 1 minus cosine 2 theta and 1 minus cosine x over 2. So this is equivalent to the square root of. So the 2 goes to the other side. That will be 2 sine squared. If that is 2 theta, then it should be 1/2 of that theta. So if it is x over 2, 1/2 of that is x over 4. All right? So again, sine squared theta is 1/2 of the quantity 1 minus cosine 2 theta. So the angle theta becomes 2 theta. Applying it to our radicand here, that will be equal to sine squared. The 2 at the right side by cross multiplication, 1/2, we cross multiply, so there will be a 2. And then sine squared. And the angle theta is 1/2 of 2 theta. So 1/2 of x over 2 is x over 4. And then dx. So we now have square root of 2. Integral of the square root of sine squared is sine x over 4 dx. So we evaluate the integral of sine, which we know is negative cosine of x over 4. But then for x over 4, the differential is dx over 4. So we need to write 1/4, and then the reciprocal is 4. That will figure out in the answer. Alright? And then plus c. So that is now equal to negative 4 square root of 2 cosine of x over 4 plus c. Okay? And finally, the integral of sine 3x plus cosine 3x quantity squared dx. So we know what to do with this one. We expand to sine squared 3x plus 2 times 2 sine 3x cosine 3x plus cosine squared 3x quantity dx. And we recognize that the sum of sine squared 3x and cosine squared 3x is equal to 1. Right? So we shall write this as the integral of 1 plus. And for this one, another trigonometric identity applies, which is equal to sine of twice the angle, so 6x quantity dx. Integrate 1 dx, that will be x. Integrate sine 6x dx, that will be negative. The integral of sine is negative. And then because of 6x, we'll be having 1 over 6. Integral of sine is cosine 6x plus c. You can now work on the following exercises. Once again, thank you for listening.